Welcome to this deep dive. Today, we're exploring something pretty interesting. This idea that unlocking intense focus, getting into those flow states, might actually have roots in your spinal health.
It's definitely a newer way of looking at things.
Yeah, it sounds a bit surprising at first glance, but we're drawing on research around what's called NeuroSpinal Synchrony.
Exactly.
And our mission really is to understand how looking after our physical structure, our spine, could potentially be a direct route to, well, enhancing mental performance.
It certainly challenges how we usually think about it. Chiropractic care has traditionally focused on pain relief, movement, that sort of thing.
Right. And performance psychology looks at flow states, but mostly from a purely cognitive angle.
Precisely. But this neurospinal synchrony model, developed by Dr. Parzak, suggests a bridge. It proposes that spinal misalignments, subluxations, can create something he calls neural interference.
Neural interference, like
Yeah.
static on a radio.
That's a good analogy. Think of it as neurological static that actually hinders the brain's ability to sustain focus, to get into that flow state.
Okay, so how does that work? How does a misaligned spine create this static?
Well, the idea is that when vertebrae are out of place, they can send incorrect signals through the nervous system. It can overload certain pathways, like the dorsal root ganglia. These are key points where sensory info comes into the spinal cord,
So they get overwhelmed.
kind of like getting too much noisy data. This disruption can mess with the brain rhythms needed for attention. It might even keep the body slightly in a fight-or-flight mode. So instead of being clear for focus, the system's dealing with this underlying noise.
That makes sense physiologically. Is there actual evidence, though? Can we see this effect on the brain?
Yes, and that's where it gets really compelling. Neuroimaging studies have started to show some interesting things. For instance, chiropractic adjustments have been observed to normalize activity in the brain's default mode network.
That's the network active when our mind wanders, right?
Exactly. So adjustments might help us switch off that idle chatter more effectively. We also see studies indicating a reduction in certain low-frequency brain waves, often linked with pain, and importantly, improvements in executive function, which relies heavily on the prefrontal cortex.
So direct changes in brain activity following spinal adjustments.
It appears so. The neurospinal synchrony framework ties this together by talking about optimizing neural bandwidth.
Neural bandwidth. How does that optimization happen?
It seems to work through a few mechanisms. First, getting the spine properly aligned reduces mechanical stress on nerve roots, those dorsal root ganglia again, which means fewer pain or disruptive signals going up to the brain.
Okay, less noise.
Right. Second, there's evidence suggesting adjustments can improve the flow of cerebrospinal fluid. Think of CSF as bathing the brain, delivering nutrients, clearing waste, pretty important for brain regions active during focus states.
So better plumbing, in a way.
You could say that. And third, particularly with adjustments in the neck, the cervical spine, there's potential to restore better vagal tone. That's linked to the parasympathetic nervous system, the rest and digest system, which helps manage stress and allows for that calm focus needed for flow.
That's quite a cascade of effects. Have we seen this play out in, say, performance context?
Yes. There was a notable trial in 2024 involving athletes. One group received these neurospinal synchrony adjustments, or NSAs, while a control group received standard care.
And the results?
Pretty significant. The NSA group reported a 23% average increase on the flow state scale. They were experiencing flow more often, more deeply. And not just subjectively, their reaction times in cognitive tests improved by about 18%.
Wow, 18% faster reaction times is substantial. Did they look at their brainwaves, too?
They did. EEG scans showed enhanced coherence, basically. Better communication between the prefrontal cortex and the parietal lobes in the athletes who got the NSAs. These areas are known to be crucial for attention and integrating information during flow states.
So their brains were literally working more harmoniously.
And it's not just that one study. We're seeing corroborating evidence from different angles.
Like what else?
Well, fMRI studies looking at blood flow have shown increased activity in the anterior cingulate cortex after adjustments that's important for focus and noticing errors. And interestingly, reduced activity in the amygdala, the brain's fear or anxiety center.
Less anxiety, more focus activation. That fits.
It does. And other EEG work has shown improvements in the theta-beta ratio, moving towards a brainwave pattern more conducive to sustained attention. Plus, a pretty significant jump, 31% in one study in gamma wave synchronization, which is linked to higher-level cognitive processing and sensory integration.
Gamma waves are often associated with peak performance states, right?
Exactly. And then there are even biochemical markers. Salivary tests have shown reductions in cortisol, the stress hormone, by about 22%, and increases in BDNF brain-derived neurotrophic factor by around 15%.
And BDNF is crucial for learning and brain plasticity.
Right. It supports the brain's ability to adapt and rewire itself.
Okay, so with all this mounting evidence, are there specific clinical protocols emerging from this model?
Yes, the NSA algorithm provides a framework. It starts with diagnostics, things like spinal thermography, to look for autonomic nervous system imbalances reflected in skin temperature patterns, and dynamic posturography to assess balance reflexes, which are surprisingly linked to focus.
So measuring nervous system function and balance first.
Correct. Then the adjustment strategy often prioritizes specific areas. The C1 and C2 vertebrae, right at the top of the neck, are key targets because of their influence on CSF flow and connection to brainstem areas that modulate alertness and the default mode network.
The gateway, as you mentioned earlier?
Sort of, yes. And adjustments in the thoracic spine, the mid-back, are often used to help reset the sympathetic nervous system, dialing down that stress response.
And after the adjustment?
There's often a flow priming phase. This might involve techniques like biofeedback-guided breathing to help synchronize heart rate variability with those beneficial gamma brainwaves, or even strategically scheduling certain cognitive tasks to capitalize on the temporary boost in BDNF.
Fascinating. It really reframes the potential role of chiropractic care. What are the implications, then, for clinicians?
For researchers, it opens up very specific, testable hypotheses. For example, does a C1 adjustment demonstrably increase activation in the anterior cingulate cortex on fMRI? Or how exactly do changes in CSF flow rates correlate with the duration of flow states? There are still questions to explore.
And for clinicians on the ground?
It could mean new avenues, maybe offering flow optimization packages alongside traditional care. It also suggests using metrics like the flow state scale or even EEG coherence tracking, not just for pain, but to monitor progress towards enhanced cognitive function and mental performance.
So wrapping this up, the core message from the NeuroSpinal Synchrony model seems to be that spinal health isn't just about avoiding back pain. It might actually be foundational for achieving and sustaining peak mental states.
That's the essence of it. It really invites you, the listener, to think about how connected your physical structure might be to your cognitive abilities, perhaps more deeply than we've typically assumed.
And considering what possibilities might open up if we start paying more attention to that spinal alignment for mental clarity and focus, really interesting stuff.
Definitely a space to watch.